In this video, I will show you how to calculate the volume of a prism or a cylinder. But first we need to talk about what a prism is. If you have congruent shapes, like if you look at this triangle right here, and if you look at this triangle right here, if it's going to be a prism, these have to be congruent. They have to be identical. So when you have congruent shapes, congruent polygons, and then those are connected by their vertices, then you have a prism. So that definitely makes this a prism. All right? Look for the two congruent bases. Let's see. So I guess we're supposed to circle the ones that are. So let's circle that. This is not a prism. It does not have two congruent bases. This is trying to be a prism, but the square on the bottom and the square on the top are not the same size, so they're not congruent. All right. Similarly, this is not a prism or a cylinder because we have a large circle and then a smaller circle, so that's not a prism. This only has the one base, so that's not a prism. Now this is a prism. This is another prism because I can see that I've got, I could look at this as being one base, and then here is another base. All right, these are congruent. And then those congruent bases are connected by their vertices. So that makes this a prism. Similarly, the next one is also a prism. This is a prism. I'll circle that. And once more, you can see that I have this triangle right here in the front is congruent to this triangle in the back. So you have these congruent polygons that are then connected by their vertices. So that makes this a prism. And once again, this next one is not a prism because the rectangle on the top and the rectangle on the bottom, one is smaller and one is bigger. They have to be congruent to be a prism. Okay, now that we know what a prism is, let's go ahead and talk about how to find the volume. The volume will reflect the space inside the prism. Now, if the two congruent shapes which form the bases are circles, then we call it a cylinder. All right, but it acts a lot like a prism. Now, here's the volume formula, if you will. The volume of a prism or cylinder is equal to the area of the base times the height. Okay, so in letters, the volume is equal to B, capital B, times H. All right, but this B represents the area of the base. So looking at problem number 2, all right, the volume is going to equal the area of the base times the height. Well, so what's the area of the base? This, you can look at this white rectangle at the top. That's going to be one of the bases. The area of a rectangle is like base times height, so it's length times width. So see the 7 down here? So this is really 7 inches right there. So the area of this base is 14 square inches. Okay, 2 times 7. So when I say the volume is equal to the area of the base times the height, the area of the base is 14 square inches, and then the height is 14, all right, because of that. All right, so the volume is going to be 196 cubic inches. All right, number 3, again, the volume is going to equal the area of the base times the height. In this case, the base is a circle, so the area of a circle is pi r squared. So this is pi times 7 squared. So that's going to be 49 pi. So when we say the volume is equal to the area of the base times the height, the area of the base is 49 pi. Again, because of the 7 squared is 49. And then times the height. Well, we see the height over here on the side is 15. So it's 49 pi times 15. Okay, so that means 49 pi times 15 is going to be 735 pi. Okay, now if that's exact, if we want the decimal approximation, 2,309.07. Okay, and this will be cubic centimeters, so centimeters cubed. All right, let's switch over to problem number 4. This gray triangle is one of the bases. So we know that the volume is going to be the area of the base times the height. Okay, so the area of the base for a triangle is 1/2 base times height. Okay, so the area of the base, the B part, is going to be, you know what, I feel like I should calculate this off to the side. Okay, B, capital B represents the area of the base. Okay, so in this case, it's a triangle. So that's going to be 1/2 base times height. So that's 1/2 15 times 9. So I'm going to put that in my calculator real quick. So 1/2 15 times 9. Hold on, my parentheses are messing up. 15 times. Okay. So that's 135 over 2. I'll go ahead and write that as 67.5. Okay, so the area of the base is 67.5. So that is going to go in right here. Okay, so that's why I'm going to write 67.5 times the height. Now, the height is the distance between the bases. Okay, on the other two problems, it happened to be vertical. It doesn't have to be vertical. Okay, let's look back at a couple of these pictures. I used green lines to show that the bases were being connected. The green lines are the height. So in this case, this is the height. See how it's sideways? That's fine. And for this problem, this is the height. This green line is the height. For this problem, this is the height. So notice that the height does not have to be vertical. It's just the lines connecting the bases. So in this case, the height is 4 centimeters. Okay, this is the height right here. So 67.5 times 4. I already have 67.5, so I can just go times 4. 270. And, that's weird. They gave us meters and then centimeters. I don't think they meant to do that. Yeah, I think that's just a typo. So I'm going to scribble out that little C and just put meters. Let's just keep it in meters. So this would be meters cubed. Okay, let's go on to number 5. This is a cube. That means all of the edges are going to be 19. So we know that the volume is equal to the area of the base times the height. We could look at this white face as being the base if we wanted to, and we would know that that would be 19 by 19. Okay, so 19 times 19, that's going to be the area of the base. 361. So the area of the base is 361. So volume is going to equal to the area of the base times the height. Now the height is the distance between the bases. And all of the edges are 19, so the height will be 19. Okay, so times 19. So that's 6,859. And we have feet, so this is going to be cubic feet. All right, problem number 6. Well, guess what? Volume is equal to the area of the base times the height. The base is a circle, so I think I'm going to calculate that off to the side, all right? We know that the formula for the area of a circle is pi r squared. Now, the diameter is 9. So the radius is half of that, so that's going to be 4.5. So it'll be 4.5 squared. Okay, so what's that? So let's see, 4.5 squared, that's 20.25. So I'm going to have 20.25 pi. Okay, 4.5 squared and then pi. So this is B. So this is going to go in right here. So that's going to give me the volume is going to equal the area of the base, so 20.25 pi times the height, and the height is 11. So I've already got the 20.25. You know what, I'm going to type it in again because of the pi. So I have 20.25 pi times 11. So that's 699.79. And we're dealing with centimeters, so volume will be cubic centimeters. All right, problem number 7. Well, the volume is the area of the base times the height. So the base is this gray triangle, all right? The dark gray triangle right here is the base. So I think I will go ahead and calculate what that is. So we know that the area of a triangle is 1/2 base times height. Okay, so that's going to be 1/2 12 times 11. All right, half of 12 is 6. 6 times 11 is 66. So that is going to go in right here. So then the volume is the area of the base times the height, so that's going to be 66 times. Now the height is not 11. The height is the distance between the bases. The height is 13. Okay, so whatever that is, so 66 times 13, 858. And we had centimeters, so for volume it'll be cubic centimeters. Okay, the base of this prism is a pentagon with area 208 square feet. No, I was confused for a second. This should be on the next page. All right, so we're talking about this picture right here. So we have a pentagon with an area of 208 square feet. So here's a pentagon. We know that the area is 208, all right, square feet. So we have the base. What is the prism's volume? So, I meant to switch colors. So the volume is the area of the base times the height. So the volume is going to be 208, all right, because that's the base, times 8, because the height is the distance between the bases, which is 8. All right? Notice the 11 does not get involved in the problem at all. So 208 times 8, 1,664. And the units were in feet, so volume will be cubic feet. All right, this prism's volume is, boom, find the length marked x. Well, the length marked x is the height, because that's the distance between the bases. So we're trying to find the height. All right, well, let's start with the formula. We know that the volume of a prism is equal to the area of the base times the height. Okay, so let's start filling in what we know. The volume of the prism is 451. So I know the 451 belongs here. So then I've got the area of the base times the height. So let's see, the area of the base. Well, let's calculate this off to the side. The area of the base, well, we have a triangle, so that's, that's 1/2 base times height. So that's going to be 1/2 10 times 11, all right, the base and height of the triangle. So that's going to be, half of 10 is 5. 5 times 11 is 55. So B is 55, so that's going to go in right there. Okay, and we're trying to find the height because that's what x is. So of course we're just going to divide by 55 now, because that will get h by itself. (8.2). Now height is a length. That'll be measured in feet. All right, so that's it for number 9. Okay, the bottom of this rectangular prism is a square. Okay, so the bottom here is a square. See if I can draw the background information here a little bit. This is a square, so that means if this is x, then this is also x, all right, because it's a square. If the prism's volume is 250 cubic meters, what is the length of x? Okay, so volume. So we know that volume is equal to the area of the base times the height. They gave us the volume, so that's 250. Now when it comes to the area of the base, we don't have any numbers for the base, but if we did, we would multiply them because the area of a square is just going to be length times width, base times height. So, well, if we multiplied x times x, what would we get? That would be x squared. So what I can do is I can go ahead and put x squared for the area of the base. Okay? Now the height is the distance between the bases, which is 10. So we have this. So we have to solve this for x. So of course the next thing I'm going to do is divide both sides by 10. All right, and that's going to give us 25 is equal to x squared. And then if you want to get x by itself, if you want to unsquare this, you have to take the square root of both sides. So that's going to be 5 is equal to x. Okay, so that is going to be the answer to number 10. All right, let's take a look at number 11. The volume of the cylinder is 45 pi cubic feet. What is the radius of the base? Well, let's see what we can do. So the volume is the area of the base times the height. They're telling us that the volume is 45 pi, so that's going to go in right here. So I'm going to have 45 pi. Okay, in here we will have the area of the base times the height. The height's the distance between the bases, so that'll be 5. So what about the area of the base? I don't know the radius. That's what we're trying to find. But I see that the base is a circle, and what I do know is the formula for the area of a circle. All right, the formula for the area of a circle is pi r squared. So that's what's going to go in for B, all right, pi r squared. So fine, I'm going to have pi r squared. So r is the only variable, so I should be able to solve for that. So what I'm going to do next is I'm going to divide both sides by 5 pi. Okay, because that will cancel out the 5 and the pi if I do that, and that will just leave r squared. On the left-hand side, the pi's cancel each other out as well. So that's going to leave me with 9 is equal to r squared. To unsquare this r and get rid of the 2, I need to take the square root of both sides. So that's going to leave me with a radius of 3. Let's not forget the units, 3 feet. 3 feet. Oh, I thought there was another page, but looks like that was the last problem. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.